work through problem 4.3 from Taylor's Classical Mechanics. This is another problem on work. It's similar to problem 4.2, which I also have a solution video for. If you're confused on this one, I would start there as I went a little more in depth with what we were doing. We know that our work is going to be integral from P to Q of f of x dx plus f of y dy. And these are the force in the x direction, force in the y direction. Our force in this case is negative yi plus xj. And our first path, we're going to go on our path A. Our point over here is given as 1, 0. This is going to be our origin at 0, 0. And Q is 0, 1. So our first path, we're going to traverse from here to the origin, and then from the origin to Q. So traveling on that first path, we're going to travel in the x direction first, and we're going from x equals 1 to x equals 0. That's in the x direction. So we're going to have our f of x, substituting in a constant y value. Our y value is going to be a constant of 0, and our x. And that's traveling dx. And then after that, we're going to go from the origin up to point Q. We're going to have a constant x value of 0. We're only going to traverse in the y direction. That's going to go from y equals 0 to y equals 1. And that's going to be f of y with a constant x of 0. And our y value, dy. Now, if you look really closely, you can quickly see that we're going to plug in 0 as our y value for our x force. We're going to get 0. So this is going to turn into a 0. We're going to plug in 0 for our x value for our y force. This is also going to be 0. So the work for this first path is 0. Now path B will give us a slightly different result here. So in B, we're traveling on a straight line from P to Q. And we're traveling from P to Q. It's important to note that we're not traveling from Q to P. We're traveling from P to Q. So from P to Q, this line right here, this line is going to be y equals 1 minus x. So we're traveling along y equals 1 minus x, and we're going from 1, 0 up to 0, 1. So we should be able to get everything in terms of x here. We know that our work is going to be the integral from P to Q of f of x dx plus f of y dy. We quickly see we're going to need dy if we're going to get things in terms of x. Dy is going to be negative dx. And our f of x is unchanged. That's still negative y, and our f of y is still x. So our f of x, we're going to substitute in our y value here. That's going to turn into x minus 1 when we take the negative of 1 minus x. Now we're good to substitute everything in. We're going to have work along this path B is equal to the force in the x direction, which is x minus 1, plus the force in the y direction, which is going to be x. We need to worry about it's going to be x minus 1 dx. This is from P to Q. Px to Qx, because we're talking about x's here, plus Force in the y direction is x times that substitution for dy, which is going to be negative dx. So our point at P of the x value is 1. We're going from 1 to 0. And we are going along x minus 1 minus x dx. So you quickly see those are going to go away. We're going to evaluate from 1 to 0 of negative 1 dx, which is the same as 0 to 1 of 1 dx, which is just x, which is going to be 1. That's the work along our path B. Now, path C is the most complicated of any of these paths. We're traveling along, it says we're traveling along the quarter circle centered on the origin. So we're traveling from P to Q along this line C. So we know our x force is negative y, our y force is x. We know that when we have a circle, our x is going to be r cosine phi. Our x, in this case, r is just 1, the radius. Cosine phi. Y is going to be sine phi, r sine phi. Our r is just 1. We can find dx, negative sine phi d phi, dy, cosine phi d phi, and then we can also find our new, kind of keep track of what's going on here of the values we're going to use, find our new y and x forces. So our new y force is going to be cosine phi. Our new x force is going to be negative y, which is going to be negative sine phi. So, using these things that we have just found for our substitutions to travel along that circular path, we can go ahead and evaluate this integral, which is going to be the work along path C, is equal to, we have to think back, okay, what values of phi are we going to evaluate between? This is at phi equals 0, and we're going to travel up till we get to phi equals pi over 2. So we're going to have phi equals 0, phi equals pi over 2. We're going to have the x force times dx. It's going to turn out to be sine squared phi. We're going to have our y force times dy is going to be cosine squared phi. All of this d phi. We know this expression in here, sine squared plus cosine squared phi, is going to be equal to the integral from phi equals 0 to phi equals pi over 2 of 1 d phi from that trigonometric identity, which is just going to be equal to phi from pi over 2 to 0, which gives us our work C is pi over 2. You can see that this work is path dependent, meaning that this force, F equals negative yi plus xj, is not a conservative force.